Therese Koch is a fifth-year neuroscience student in Dr. Todd Roberts' lab. We asked all of the speakers to send us a one-liner of anything they wanted us to say about them, and Therese said that in her free time, she is an avid knitter, crocheter, and embroidery artist, and is addicted to buying craft supplies. So her talk today is entitled Baby Bird Babbles, What Songbirds Can Teach Us About FOXP1 Syndrome. So Therese.
Can I go up here? Okay. Just making sure I'm standing in roughly the right spot. So, would you believe me if I told you that I could implant an idea in your mind just by sending the right combination of vibrations through the air? It might sound like magic, but it's very real, and I'm actually doing it right now. As we speak, my brain is translating ideas into words, into sounds, into movements of my mouth that are causing waves of pressure to travel through the air to your ears, where your brain decodes them. In case it's still unclear, what I'm describing is language, and we as humans are experts at it. Not only that, but we learn language effortlessly as babies without any kind of instruction manual. At least that's the case for most people. Like with anything so amazing and so complicated, there's a lot of ways that language learning can go wrong. Today, I'll be talking to you specifically about FOXP1 syndrome, a disorder caused by a mutation in a single gene which causes people to have extreme difficulty speaking. We know that disrupting this gene causes language problems, but exactly what step in the process is affected remains poorly understood. To address this question, I and a group of awesome scientists from my lab decided to mimic FOXP1 syndrome in a bird called the zebrafinch. Like humans, zebrafinches learn their songs as babies by listening to adults. We can break zebrafinch song learning down into two main phases. In phase 1, baby birds must memorize the song of an adult bird that they want to copy. Then in phase 2, they practice making all different sounds until eventually they can perfectly replicate that example song. In our experiment, we let one group of birds memorize the adult songs like normal. Then we manipulated their brains to mimic FOXP1 syndrome to see what effect this would have on the subsequent practice stage. To our surprise, these birds actually learned to sing perfectly good songs, which tells us that FOXP1, at least in the part of the brain that we manipulated, isn't necessary for the refinement of vocalizations through practice. In a second experiment, we manipulated the birds' brains before they ever heard song. So now it's affecting both the memorization and the practice phases. Unlike the first group, these birds did not learn to sing. They still made sounds, but they were nothing like the example songs they were trying to copy. Overall, this tells us that FOXP1 is necessary for the formation of a song memory to guide subsequent vocal learning, but not for the practice and performance of song once that memory has already been formed. This gives us not only more insight into how these birds are learning to sing, but also into what aspects of language learning might be more affected in people with FOXP1 syndrome. And in the process, we take a baby bird-sized step forward to better understanding the magic that is human speech and language. Thank you.